Hi, and welcome back to this series of training videos covering the latest features and benefits that we've added to Fusion software. This version is 4.16, and there are a series of videos covering specific topics. And today we're going to be talking about the ease of creating a part program and how we align that program to the component's current position. Let's take a look. Let's take a look at how we create a program from scratch. Here I've got a part that I've already scanned. I've got the images of each position that I visited on this part stitched together in my scanned image view. Here is my live view, and you can see all of the other features on this part that we've yet to measure. So let's start to create a program. I'm going to jog the machine to this position and zoom in on the live view. And let's just remind ourselves of the tools that we have available to measure various features. I've got tools for a circle, line, point, all the conventional tools that our system and most other systems on the market would have. My personal favourite, one of my personal favourites is this guy here, auto select feature. I'm going to put that one on. So let's just remind ourselves of how we start to measure features. I've got the mouse drag tool there. And I'm just going to scan over that edge. I've created a line and OK that feature there. Let's use the mouse to drive the machine over to the next feature I want to measure. Without changing the tool type, you can see that the auto select tool is going to change that from a line tool automatically to a circle tool. So that's the first feature that we have that makes life easier for the operator. So very quickly moving on to some of the newer tools, I'm going to talk about one-click feature now. So one-click feature gives us the ability to click on a feature, the machine will drive to that position because it wasn't actually in the current field of view, and measure that feature there. And now, as I hover over features, the one-click feature will preview what it recognises as the feature to be measured. So I'm going to click on that as I agree it, and then using a combination of the mouse drag and one-click feature, we can click on that one there, there's the feature, click on that one there, and so on. So already you can see how much easier that is. We're not having to define tool widths, we're not having to define feature types. I'm just clicking on the edge of the feature that I want to measure, and the software is making all the right decisions for me. So one of the other new tools that we've got is all features in an area. I'm going to drive to a larger area here. I'm going to zoom out. And in the current live view, I've got half of that circle, all of that circle, a part of that circle. But if I zoom out to my stitched image, I can see I've got 1, 2, 3, 4, 5, 6, 7, 8 features here. And I'm going to use a tool called All Features in an Area and just drag a box over these features. And you can see that that box divides itself into 4 smaller boxes, each of which represents one field of view. So just by defining an area with some features in it, the machine will then understand that it needs to go to all of those positions within that box, grab the edges of the features that are in that area, and then glue them all together when it's completed the process. And then at the end of that process, we have some measured features. Here we are. And you can see that it successfully recreated the features here in our inspection, the 6 circles around the outside, the larger diameter in the middle. I haven't had to tell the software what these features are, predefine the tool widths or any of those things. I just dragged a box over that area. So I don't see how it gets a lot easier than that. The next stage would be perhaps to start dimensioning these features, and we've got new features and benefits within this version of software to assist the user with that as well. So I'm going to double click on this circle here and create a diameter dimension. We can open that diameter, we can call it, give it a name, and we can create a specific tolerance. But then I'm going to use this copy dimension from similar features function, And when I do that, you can see the software has created the same dimension on all other similar features using the same tolerancing information and so on. So I can start to build up a report very easily. So I've created 6 dimensions there from 1. Let's use the all features in an area tool in a different way. This time I'm going to jog the machine to this cluster of very small, much smaller features. So jog here. Let's zoom in. Can you see how jog here, mouse drag, the stitched image, zooming in, zooming out, it makes it very easy to drive the machine. I'm going to go to a bigger zoom position here to increase magnification, and let's show you how the software can make sense of this kind of a cluster of features. So I'm going to draw a box over these features here, and you saw there that it's basically measured all of those features over here. And if I create a dimension here between this line and this line, and maybe a dimension on that radius, again I can copy to all, and we've got a report here that's starting to build quite nicely. Okay, so if we look at reporting, I'm going to go to graphic details and tabulated dimensions. Let's just preview those reports very quickly. There's my graphic details report, dimensioned drawing, as you're very familiar with, I'm sure. And if we go to tabulated dimensions, you can see with those few mouse clicks, we've not only created measurements on that part, we've created 15 or so dimensions with a few mouse clicks. So creating the information and getting reports out of the system, super easy. Okay, so the next stage would be, we've created a program, let's run the program. As you know, we've got a teach and repeat style of software we're famous for with our graphical user interface. We can do all of this without even touching the keyboard. And just to demonstrate that, let's hit the play button, and we can see that everything that we've created just replays in the normal way. Using the tools that we've created, each feature is remeasured, the dimension is replicated, and populates the report that reports that we've assigned with this inspection. So that's the inspection summary, components passed, and in a matter of seconds we've measured that component. So next component comes along. If this was a fixture situation, I would simply remove that component, put the next one in, we would run the program in its current position. But what if we've no fixturing and we're just going to take that component off and put it somewhere completely new? This is another enhancement to 4.16 software. What we're going to do now is drive the machine approximately to where the component is today, and pick a group of features that we can recognize. Let's say these 2 circles. And if I zoom out, you can see that over here is the program template. And if I open my workpiece coordinates, I'm able to drag that program and visually align it on top of the current view. So this is a live view, this is where I am, this is where the program is going to run, which clearly isn't in the right position. So if I simply use the mouse and drag that so I can visually overlay that on top, you can see that I can make that alignment correct. So that's good enough. We'll close that and let's run the program in this new position. There we go. No remeasuring reference features, no recalculating, no keyboard entry, just drag the program to its new position and run it where the part is. Okay, so that's a quick summary on how quickly and easily we can create a vision program. There's lots of methods and we've only touched on it in this short video, but I also want to cover a touch trigger probe program. Let's clear this inspection down. I'm going to go for a new inspection and let's select a new touch probe, put that currently loaded probe away and pick up a more appropriate probe for this component. There we go. Using the joystick to rapidly drive over to the machine, bring the stylus somewhere close, and using the graphic here I can see which of the styli that are loaded into this configuration is the active one. I can see the Z- probe is the currently active probe. That's the correct probe because I want to measure a plane. Let's come somewhere close to that. I'm going to call a plane on this new inspection, and using the new touchscreen probe moves screen, I can simply ask for a probe move in the Z- direction. So you can see how easy it is now for me to make these probe moves using one touch on the screen. I get a nice CNC controlled, speed regulated touch probe move, very safe. I'm going to call that a reference feature and move on and measure some more features. Okay, so having measured some more features in the conventional way, you can see that we've created a simple program here using the touch probe. And obviously, if I was to measure to play that program now, the program will run in its current position as you'd expect. It goes to the safe volume, drops into these features, and we're running this pretty fast. And I use the new touchscreen probe move screen very successfully for diagonal moves, probing that cylinder, all very easy. And you can see how quickly we were able to execute that program. But as before with the vision program, what happens when I want to move that part and I don't have a fixture? Well, I can move the part to a new location. You can see that we've got a completely new location now. So as with other systems and previously with ourselves, we would have to now redefine those reference features so that we can recalculate the position of all these features in a program that might be much more complex than this. But now it's a much simpler process. What I can do now is open the workpiece coordinates feature in the software, and I'm simply going to drive the machine so that my probe is approximately in the center of the reference feature. The reference feature in this case, just to confirm, we can see with the graphic here, the reference feature is the top left-hand corner there. We have a plane on the top face of the part. We have a reference feature here to determine the origin, and we've got an alignment between that and the circle to the right. So if I put the touch probe in the center of that circle, around about level with the plane, open the workpiece coordinates form, and I'm simply going to say set workpiece coordinates to the current probe position. So current probe position is where I need reference to be, and now I can visually see that my touch probe looks as if it's right in the center of the reference feature. It's exactly where I want the program to run. So like the vision application, we drag the program template over to the image of the part. With a touch probe program, I'm putting the probe in the reference position and just saying run it here. So let's try that. I'm just going to hit play. And again, I haven't manually remeasured any reference features, and you can see that we've successfully retaught the program position in a completely new place. So lack of fixturing, no longer an issue at all. Okay, so in this video we've covered how easily and quickly we can create vision programs and touch probe programs. We've asked the software to decide what features are. We can group features together and the software make a decision about which tools to use and what the features actually are. We've repositioned programs by simply dragging the program over or visually aligning it. So we're taking away those need to measure reference features and making the user interface a far simpler process. I want to just finish this training session by reminding ourselves of another way that we can create a simple part program, and that's by using, instead of features that we're going to measure on the part, we can use a DXF file, a CAD file that already has the information of the features that we want to measure. So just as a quick reminder, let's go to a new inspection here. I'm simply going to import a DXF file which describes and contains some of the features that I want to measure on this part. I'm going to choose to import this DXF as an inspection template, and I'm going to select on my measure percentage scale bar here 90%. So we're going to measure 90% of the length of a radius or the length of a line, just as you would in reality. If I hit finish, you can see already we've got a program template. Here's the program that the software's created. But as before, if I run the program now, it wouldn't be in the right position. But here's the difference. If I scroll out, you can see in the software world, here is the template of the program. Here is my current actual position. So if I open workpiece coordinates, I can simply drag that program down into the locality of the part, and by zooming in, I can see when the program features are aligned with the part features. Simple as that. Let's close WPC, and now it's a case of we can add dimensions either before or after this process, add them to the template or add them to the finished program, but at any point we can run that program and it will simply run in this position. I haven't had to create any reference features, I haven't had to redefine references. Import the DXF program as a program, drag it to the current part position, hit play. Thanks for watching.
Question.